Hello, we're looking at problems 54 and 55 on page 313 from lesson 5-3. It says write a recursive formula and an explicit formula in slope-intercept form that model the arithmetic sequence. How does the recursive formula relate to the slope-intercept form? So the first one for number 54 is 3, 5, 7, and 9. Oops, sorry, I forgot to clean my board. So we have 3, 5, 7, and 9. And if you recall from a previous lesson, they talked about recursive and explicit formulas. You can find it on page 275 and page 276. You can find both of those formulas. And the recursive formula is A sub n, and that n represents the term in the formula, equals A sub n minus 1 plus d, and d is the common difference. For the explicit formula, it is A sub n equal A sub 1. Sub 1 is just the first term in the sequence, plus n minus 1, where n is the term that you're referring to, and d. So for example, looking at here, my first term is 3. My second term is 5. My third term is 7. And my fourth term is 9. And I believe it was a dot, 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 so that means that it keeps going on. Now I find the common difference. So if I look at here, the common difference from 3 to 5 is 2. From 5 to 7 is 2. And from 7 to 9 is 2. So that means my common difference, because all of them have a difference of 2, my d equals 2. So we'll say d equals 2. So I can write my recursive formula. Super easy to do that. It's just A sub n equals A sub n minus 1 plus 2. And my explicit formula, I'm going to have to erase some of this. Because I have to work it out for the explicit formula. My explicit formula is A sub n equals A sub 1. So my first term is 3. So that's my A sub 1. So we'll put 3 plus n minus 1 times 2. So I need to solve this out. So I get A sub n equals 3 plus 2n minus 2. Combine my like terms. I get A sub n equals 2n plus 1. So they want it in slope-intercept form, so I'm just going to change my A sub n to y, my n to x, and there you have it. And they want to know, so this is my explicit form, and this is my recursive, and here's my slope-intercept form. And I want to know how my slope-intercept form relates to the recursive. And I can see that my common difference too is also the slope here too. So that's how they relate. Let's look at the next one. So I'm going to erase this. So the next one we have -1, 3, 7, and 11. So once again, that means my first term is 1. My second term, or my n2 equals 2, is 3. My third term is 7, and my fourth term is 11. Let's look and see if we can see the difference. From -1 to 3, the difference is 4. From 3 to 7, the difference is 4. And from 4 to 7 to 11, the difference is 4. So that means my d is equal to 4. So if I put in recursive form, if you remember the formula, it's going to be A sub n equals A sub n minus 1 plus 4. And so this A sub n, and this is just a review of a previous lesson. So that means that if I want to find, let's say if I want to find my third term. Well, in order to find my third term, I need to do 3 minus 1 plus 4. So that means I need A sub 2 plus 4. So that means I have to know what my a sub 2 term is. So that means I need to come over here to my second term, which is 3. So a sub 3 equals 2 plus, I'm sorry, that's not 2. It's not a 2. That's a 3 plus 4, and that is equal to 7. And this is correct because my a sub 3 term is 7. That was just a real quick review of what that is. So let's leave this here. This is my recursive formula. Now let's look at my explicit formula. And so that's going to give me a sub n equals, I need my a sub 1, or my first term, which is negative 1, plus n minus 1 times 4. So I'm going to evaluate. So I have a sub n equals negative 1 plus 4n minus 4. I'm going to combine my like terms. So I get a sub n equals 4n minus 5. So I want it to be in slope-intercept form. So I'm going to change my a sub n to y, my n to x, and I have 5. And once again, my common difference and my slope are the same. So that's how my recursive formula relates to my slope-intercept form. I hope this helps.